Hello, good evening. I'm Suji Elizabeth George, your online chemistry tutor. I'm from Cochin, and may I know your name? Okay, you are Nima. Hello, Nima. How are you? How are your classes going? Oh, yeah, it didn't start, right? You're in ninth? Okay. Okay. So, I'm Suji, who is from Cochin. I have a postgraduate degree in pure chemistry and also a BEd degree in physical science. And I deal with physics and chemistry, and I take the both subjects for classes 6 to 10 standard. So, if you have any doubts, I want you to ask in between. You just have to raise your hands, and I want you to have a notebook with you in case if you have to write something. Okay, and your cameras should be on. Sorry for that. The cameras should be on. I hope I am clear and audible to you. Okay, Nima. So let's start. Yes. So today we are going to take the third chapter from your textbook. It is atoms and molecules. So what do you know about atoms? So from smaller classes you have been studying what an atom is, right? Yes. Yes, smallest particle of an substance, any substance. Then what do you know more about it? Okay. Then, so if it contains same kind of atoms, we call it an element. If the substance contains same kind of atom and different kind of atoms, we call it as a compound. Yes, then atoms combine together to form. Yes. So, we were saying that atoms, two or more atoms combine together to form molecules. Okay. So, atoms are fundamental building blocks of matter, the smallest unit that retains the chemical properties of an element. Molecules are a group of atoms bonded together, forming basic units of chemical compounds. Okay, let's study more about this. What do you know about the history of atoms and molecules? Who found out that each substance is divided into atoms and molecules? Have any idea? Okay, let's see about that. Early ideas about atoms. Maharishi Kannad, a famous ancient Indian philosopher. He lived during 6th century BC. Okay, and he was the first to propose the idea of an indivisible particle. And he said that if you cut something into pieces and keep on cutting it, we will reach a point where we are not able to cut it or divide it further. And he named that Parmanu, which means the smallest particle of matter that cannot be divided further. Also, Pakudha Katyayana, a contemporary of Maharishi Kannad, said that these smaller tiny particles combine together in different ways to form the substances that we see in our daily life. Okay, again, Greek philosophers. These are all philosophers. There ain't any scientists during that time. So, our philosophers will be giving these theories, and scientists were someone who proves that whatever that was said by the philosophers are correct. So, Democritus and his teacher Leucippus, they are Greek philosophers. also proposed something similar to it. In those days, some people in India might have da, said something about this, and in Greek also they would have found it out. But there isn't, like us, we are connected like this. There isn't something or medium to connect with each other. Okay, they will be doing their research. Indians will be doing their research, and it goes on. Okay, so they called these invisible particles atomos, which means indivisible in Greek. And now you know where the name atom comes from, right? Okay. So, now, who is this? Mm-hmm. So these philosophers were someone, they give concepts, their ideas out, but that has to be proved, right? So in 18th century, there was a scientist called Antonio Lavoisier, and he proved that whatever Democritus or Leucippus said, whatever Rishi Kanad said, was true by giving certain theories. Okay, and he found also. So this is the father of chemistry, and he has put forward some amazing laws which were still useful and relevant in chemistry. Okay, he was born in France in 1743, and he wore a wig. Yeah, even our Isaac Newton has got a wig, right? Yes, looks funny, but that was, shows their position or class in the society. Okay, so do you want to know what he discovered? He discovered Mars is neither created nor destroyed in a chemical reaction. When a chemical reaction happens, whatever is reacting, the mass or the weight that we take as the reactants will be equal to the mass of the products that is formed. And also he found out other things like oxygen is something which helps in burning. Also he found that water is made up of hydrogen and oxygen. That is about the father of chemistry, Antonio Lavoisier. Okay, let's see what Lavoisier has to say more. Lavoisier has proposed two chemical laws. Okay, law of chemical combination. Okay, how these indivisible particles that who said Democritus or Leucippus said combine together. What happens when it combines? So his two laws, which is very important till today, is the law of conservation of mass. Masses can be neither created nor destroyed in a chemical reaction. So here we are taking 2 grams of hydrogen, 16 grams of oxygen. We are weighing it, and the experiment is conducted in a consoled bar. Okay, nothing can't escape, or it is all there in one system. Okay, and they are before the experiment and after the experiment, they are, yes, weighing it, and he found that the water formed was exactly 18 grams. Okay, so Mars is neither created or nor destroyed in a chemical reaction. Okay, the second law states that what? Law of constant proportion. This Lavoisier, along with other scientists, noted that many compounds were composed of, you can see this right on your right hand side, many compounds were composed of two or more elements, and each compound has same elements in same proportion irrespective of where the compound came from or who prepared it. Meaning, for example, if we take water from the tap and then we are taking water that we have prepared in the lab, it is very difficult, but still real imaging, or water from the river, water from the pond, freshwater lake, ocean, all the water we are taking and we are finding out what is it made up of. And we see that everywhere it is made up of two hydrogen and one oxygen. That proportion, or that the amount or the thing that is in there while making water, or the composition of water is the same everywhere, and that's led to the law of constant proportion, which is also known as law of definite proportions. The proportion doesn't change. Okay, this law was stated by Proust, another scientist. Okay, he was also a part of Lavoisier's team. Now, so what does law of constant proportion say? In a chemical substance, the elements are always present in definite proportion by mass. For example, water is H2O, right? The ratio of mass of hydrogen. What is the mass of an hydrogen atom? It is 1. And oxygen atom is 16. Okay. So in the case of water, the formula says it's H2O. 2 atoms of oxygen means what will be the mass? 2 atomic mass units. Okay, 2. And oxygen is 16. And if you make it simplified, we can see that hydrogen and oxygen, 2:16, 2 mass of hydrogen reacts with 16 by mass of oxygen to give water, 18 grams of water. And if you simplify it, we can see that it combines in a ratio of 1:8. So no matter if you take it from a river, tap or rain, the formula will remain the same. That is what we said. Again, these were said long ago, and scientists did more and more experiment to prove that this was correct. And finally, Dalton was the one who proposed a theory that, and confirming that whatever Lavoisier was said was true. Okay. So in earlier days, so many scientists came forward to give appropriate explanation for law of chemical laws, but it was a British scientist called John Dalton who provided a basic theory about the nature of matter. And Dalton picked up the idea of divisibility of matter, which was still then just a philosophy. That is, there was atom and all, and which was still then a philosophy. He took the name atoms. The name atom was given by our Dalton, John Dalton. Okay. So, and his theory, the theory that Dalton proposed, was based on the laws of chemical combination. Okay. So, let's see what Dalton has to say. So, he first said, all matter is made up of tiny particles called atoms. Yes, that is what all the other philosophers and scientists said, which takes part in chemical reaction. That is the first one. This is an important law that you need to study. These postulates, these things. Okay. Even though they have drawbacks, it is still relevant. So we have to study all the things. No, then only we will come into conclusion. So many other things. Then later on, so many scientists had found out so many things. Even Einstein also. Okay. So next one is, atoms are indivisible particles which cannot. At what century? In which century did he say this? In 18th century. Okay. So in 18th century, using his limited circumstances, he said atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Okay, do you agree with it? Okay, let's see. Then, Third postulates that atoms of a given element are identical in mass and chemical properties. Okay, that also he said. What a given element, for a given element, for example, if it is chlorine, for chlorine, the mass of chlorine will be 35 in all the cases. Okay, and its chemical properties also will be the same for all atoms. Okay, then again he said atoms of different elements obviously have different masses and chemical properties. The chemical property of sodium is not equal to the chemical property of chlorine. But still, he also said atoms of different elements have different masses. Okay, and chemical properties. We'll see whether this also is true or not. Then, fifth postulate is that as the atoms combine in a ratio of small whole numbers to form compounds that we have seen 1 is to 8, 1 is to 2, all those things, right? Then the relative number and kind of atoms are constant in a given quantity. If it is, we are taking water, the number is H2O. So for one oxygen, 2 hydrogen is needed. In case of another like NH3 ammonia, for one nitrogen, 3 oxygen is needed. So that will be a constant for a given compound. So these were the postulates, okay, of Dalton. But there are drawbacks. Some of these were not true. Later on, scientists found out that atoms are divisible. You know that, no? That is why electricity is happening. There are something which is making the electrons, there something which is flows through a conductor. What? There it is electrons. Where does electron come from? So to explain electricity, scientists had to say there are some charges inside this atom. Atom has to be divided. There is some subatomic particles inside it, and thus they made so many other researchers, so many other testers, and then find out that there were some drawbacks in Dalton's postulate. This thing, that first thing that you know about it, already know, atoms are not indivisible, or simply you can say atoms are divisible, right? All atoms of an element are not the same, was said by Dalton earlier, but there were isotopes, and different atoms can, different atoms also can have same masses. That is in the case of isobars. These two things you will be studying later in this class. Okay, not in this class, in 9th standard. Okay, atoms can be created. He said atoms cannot be created, but in nuclear reactions, atoms are created. So nuclear reactions usually happen in sun. Sun's energy is produced by nuclear fission and fusion, where atoms are, or the nucleus is combining together or breaking up. Okay. And also, he couldn't explain the formation of carbon monoxide, CO, and CO2. Also, there is H2O2, hydrogen peroxide, and H2O water. Why are they forming in that? He said it can't be formed. It will always be in some kind of definite proportion, and it is definite and all, he said, right? Okay, that's about the drawbacks of Dalton's postulate. We will see in the next chapter. Atom's structure. Okay, so the structure of atom, you know that there is a nucleus in the middle, and electrons are revolving around this atom, the same like the planets revolving around the sun. And electrons are being placed at different energy levels. So we will study more about this, and also the names and symbols to represent these atoms in the coming portion. Okay, so please wait. So these were about what? Atoms, the postulates, the researches that scientists have done to prove that whatever that philosophers has said was true, all those things. Okay, now let's move into our we'll take our textbook. So there we have given about the laws of chemical combination, Dalton's law, and all those things, and we have already learned about it. Now, what is an atom? So here you can see, maybe already know, no? The smallest atoms are a very small particles, smaller than anything that we can imagine or compared with. Yes, we have already said it. It is the smallest particle of any element. Okay. So if you take it, if you are thinking about a big cricket stadium, huge one, atom, the nucleus of an atom is less smaller as like a ball. Okay, the cricket ball. That is how, yeah, if you measure, compare the an atom and a nucleus. And again, this whole atom is tiny, very tiny, that it is measured in nanometers. Its radius is measured in nanometers. That is, what is 1 meter is equal to 1 by 10 raised to 9, or 1 meter is equal to 10 raised to minus 9. That means 0.00000000. You have to put 9 zeros. That tiny is the radius of an atom. So atoms are measured in, what is the measuring unit of atom? It is that small. And even nucleus inside the atom is even more smaller. Okay, it is in nanometers. Shall I make it more bigger? Zoom it. Okay, 1 second. So atomic radius is measured in nanometers. So if you compare the size of an apple, the radius is minus 10 raised to minus 1. That is equal to 1 by 10, or you can say that 0.1 meters. Okay, it might, yeah. And is the size of an ant is 10 raised to minus 3. Grain of sand is 10 raised to minus 4. And then we can imagine how small is a hydrogen atom. It is 10 raised to minus 10. That means 10 by 10 raised to minus 10. That means point and 10 zeros. Okay, that small is an atom. Okay, now, so these atoms, there are, how many atoms are there, or how many elements are there in total? There are 118, 19, in some books it is 19 elements, and among them only 92 are naturally formed and all the others are made by man. Okay, so these many elements are there. So can you name a few of elements that you know? Okay, there is hydrogen is the first one. Then comes helium. It is the second one. Have you ever seen a periodic table? Right. Yes. So hydrogen is always written on the left hand side. There is one group down, hydrogen, and helium is at the extreme right side. Okay, right. Yeah, helium is number 2 and it belongs to 18. We'll see what it is. Okay, now hydrogen is there, helium is there. After that it comes lithium, beryllium, boron. You are not familiar with all these things. Any other things that you are familiar, you can tell me. Yes, nitrogen, chlorine, correct. Then sodium. Anything else you have studied about so many minerals in biology class, in smaller classes? minerals that are useful for human beings for their maintenance of their body. Yeah, potassium, calcium, magnesium, then carbon, oxygen. See how much I'm taking a lot of time in writing it down. Mercury, lead. Okay, so there are so many elements, and Dalton was the first scientist to use symbols for the elements in a very specific sense. Why do we have to use symbols? Because it is very, if we are doing an experiment, writing down the whole name, nitrogen plus oxygen giving nitrogen oxide, nitrogen dioxide, all these things, when you write it down, it will take a lot of time. And instead of that, Dalton proposed that we will use symbols for an element, also meant a definite quantity of that element, and it is one atom. Symbol means if you are saying he chose O for symbol for O or circle for oxygen, that means it is one atom of oxygen, right? That is what he meant. So thus, and Berzelius also suggested symbols of elements from one or two letters of the name of an element. So these that we are seeing is the symbols for elements proposed by Dalton. Do you think it is easy to write? We will forget, huh? This is Mercedes-Benz or what? Phosphorus. And if you want to write mercury, we will be putting a circle, and then I don't know how many small circles are there giving borders. It is difficult, right? So, another scientist, Berzelius, suggested that symbol of elements are made from one or two letters of the name of the element. Okay, so let's see how that is going to be. In the very beginning, the names of elements were derived from the name of the place where they were found. Okay. For example, copper was taken from Cyprus. So, and some names, copper is Cu. Okay. Some names were taken from specific colors. For example, gold was taken from the English word yellow. Gold, yellow. Nowadays, how are we going nowadays? IUPAC. What is IUPAC? International Unit of Pure and Applied Chemistry is a scientific organization which approves the name of elements. They have, yes, they have given names to each element using certain rules. Okay, you can say it is a rules. So, many of these samples, first one or two letters of the element's name in English were taken as the symbol. So, can you tell me an example? Oxygen, if I'm saying oxygen, and next one is lithium. Nitrogen, aluminium. Okay. Here, the symbol of oxygen is the first letter O. Lithium, we took first two letters Li. For nitrogen, again we took the first letter. For aluminium, according to, not we, according to IUPAC, they took Al, right? So first letter of the symbol was always written in a capital letter, the uppercase, and the second letter smaller case. For example, hydrogen, aluminium, not capital L, A, L, not, both are not capital, only A is capital. Cobalt, etc. Then again, symbols of some elements are formed from the first letter of the name and the letter appearing later in the name. For example, if you take zinc, we are not taking ZI, they have taken ZN. Any other letter which comes later on. Okay, so another example is chlorine. So chlorine is written as C is taken and L is also taken as Cl. Another example. Okay, we'll deal with it later. Okay, so thus symbols of elements were found out. I think our time is up. Or let's do this and go. Yes, we'll finish it off. So other symbols. This is another important thing that we need to take care of. For example, sodium is written as Na. Where does this Na come from? Any idea? There is no N or there is no A in the name sodium. So, some other symbols are taken from the names of elements in Latin or Greek. For example, iron, IRON, is called Fe from its Latin name ferrum. Sodium is Na from natrium. Its Latin name is natrium. Potassium is K from its Latin name kalium. Thus, each element has a name and unique chemical symbols. Okay, this is how the the element symbols have been written. Okay, so here I want you to learn the names of and symbols of elements from 1 to 20. So in next class when you come, I want you to write down the names of 1 to 20. 20 is the number, atomic number. If you Google, you will get the periodic table, and it has been written as 1, 2, 3, 4, 5, 6 and all. Take those numbers, write 1 to 20 elements, and at the other side write the symbols used. Okay, some of the symbols are given. So 1 to 20 does not include argon, barium, and cobalt, copper, gold, iodine, all those things. And after studying this, we will be learning about some other important elements that we will be learning in our further classes as well. It will be good. Okay, so this was about it. In this class, we have studied about atoms and molecules, the history or the philosophers who told about it, and the scientists who proved that it was correct, the laws of chemical combination, and the law atomic theory, which was put forward by Dalton by studying the law of chemical combination theories. And then he proposed all these things. He proposed that atom is the smallest particle and all, and he gave the names of some of the elements and how can we write the symbols. Berzelius also suggested certain ways, and finally IUPAC has confirmed and given us a periodic table with all the elements written and all the symbols needed. Okay, so we will study about all these things in next class. Till then, please read it, study the laws of chemical combination, also the postulates, atomic theories is very important, and also I want you to learn and write down the name of elements from 1 to 20. And if you are finding it difficult, you can use mnemonics, and I'll teach you how in the next class. Okay, so till then, bye from here. So have a nice time. Okay, bye bye.